All right, let's go ahead and talk about the ideal gas law, which is PV equals nRT, sometimes called PivNert. The relationship between pressure, volume, and temperature and number of moles are indicated by the combined gas law. Because these variables are related in such a way, what it does is it provides a constant, which is R, which we call R. It's called the gas constant. And we can use that to solve for any of the variables if we know the other three. So let me go ahead and talk about what that means. So if we have pressure, volume, and temperature, we have three variables. We can calculate the moles. If we have volume, temperature, and moles, we can calculate the pressure. And we can use this using PV equals nRT. And so using the gas constant R, the relationship between these variables can be used to solve for one of the unknown variables. This here is the equation that we use. So it's PV equals nRT. It's really simple. R is a constant. We always have R. If we have three of the four other variables, then we can solve for the fourth one. So we have three of the four, we can solve for the fourth one. It's just plugging it in. So for example, if we had volume, moles, and temperature, we can solve for pressure there. Again, R is a constant. P is pressure, V is volume, N is moles, R is gas constant, T is temperature. Something to keep in mind, temperature has to be in Kelvin. Volume, very important, has to be in liters. In the combined gas law, where it's P1V1 over N1T1 equals P2V2 over N2T2, that one, it didn't matter. It doesn't matter if it's milliliters or liters. In this one, it's important that the volume is in liters. So when we're using PV equals nRT, the volume has to be in liters. The temperature has to be in Kelvin. The ideal gas constant, it has been experimentally determined and is the same for all gases. Pretty amazing. So it doesn't matter what gas we're dealing with, it's going to have the same constant. These are the gas constants that we're going to be using. All right, so notice how there's three different gas constants. Now all three of them are actually equivalent to each other. They are the same, but notice what is the difference between each one. The difference between each one is each one has a different unit for pressure. So when it comes to calculating some sort of unknown, for example, let's say we want to calculate temperature. When we go to look at the gas constant, the one we choose is going to be dependent on the units of pressure. So for example, if we're given 3 atmospheres of pressure, well, because it's in atmospheres, we're going to use the 0.0821. Let's say we're given 740 millimeters of mercury. Well, because the pressure's in millimeters of mercury, we're going to be using the 62.4. And so whatever unit of pressure we're given, we just choose the correct R value. Now notice the units for volume, all of them are liters. Notice the units for temperature, all of them are Kelvin. And notice the units for the quantity, they're all in moles. So you have to have your N in moles, you have to have your T in Kelvin, and you have to have your V in liters. If they're not, then you convert them to those units. So again, you must be sure your known values are in the correct units before working through calculations. Very important. So if you're given milliliters, you got to convert to liters. If you're given Celsius, you got to convert it to Kelvin. If you're given grams, you've got to convert it to moles. And you use that chart there to help you. We're going to go through some practice problems. These problems are really simple and straightforward. The big thing with these problems is determining when to use the PV equals nRT versus when to use the combined gas law, which is the P1V1 over N1T1 equation. But we'll talk about how you can do that. All right, have a great day.